You know that feeling when your car starts making this tiny, almost imperceptible clicking sound,
Oh, yeah, definitely.
right? At first, you just turn up the radio. You tell yourself it's nothing, just a, quirky fan belt.
You just ignore it and hope it magically fixes itself.
Exactly. But then, like a week later, you are stranded on the shoulder of the highway with a blown transmission, and you suddenly realize that tiny click was actually your engine screaming for an intervention.
It's so true. The human brain is actually hardwired to optimize for the immediate path of least resistance.
Right.
In IT, we call that normalizing a deviation. And it is the number one reason small networks collapse overnight. We condition ourselves to work around the friction instead of, actually investigating the source of it.
And today, our mission is to look at the digital equivalent of that clicking engine. We are taking a deep dive into how seemingly minor, mundane tech annoyances, the kind you just want to click X on and pretend didn't happen, can actually be the loose thread that unravels a massive cybersecurity threat.
It is a phenomenal case study today. It perfectly illustrates the hidden mechanics of a compromised system and the sheer danger of treating a symptom without diagnosing the underlying disease.
We have our hands on a fascinating real-world incident report from Cowabunga Computers, an IT service company based out of Oahu. Okay, let's unpack this. Our goal today is to walk you through exactly what happens when professionals pull back the curtain on a broken system.
Yeah, you're going to learn how to spot these subtle red flags in your own digital workspace.
Right, and understand the real financial and security costs of unauthorized access, and see how the plumbing of your daily software actually works.
This is foundational knowledge. I mean, the threat landscape has evolved far beyond, obvious viruses that lock your screen. The most dangerous compromises today are designed to look like boring everyday glitches.
So whether you run a 50-person operation or you just manage your own personal digital life, understanding these hidden mechanics is crucial for your security and your wallet.
Absolutely.
Let's set the scene. We have a small business in New Valley, a neighborhood on Oahu. They are dealing with a problem that virtually everyone listening has dealt with. OneDrive just stopped syncing.
The dreaded file sync failure. It is literally the bane of the modern collaborative office.
It really is. So the business owner and the office manager, they're trying to collaborate on a set of shared files. They rely on real-time sharing to get their invoices out and manage clients, and suddenly it just halts.
Everything grinds to a stop.
Yeah, the owner updates a spreadsheet, but the office manager is still seeing yesterday's version. Work is just piling up. It's like a digital traffic jam on a two-lane bridge. Everything is backed up and nothing is getting through.
What's fascinating here is that when we talk about cloud synchronization, we tend to think of it as a magical, invisible wire between two computers.
Right, like they're just magically linked.
Exactly. But in reality, it is a highly complex, continuous handshake of authentication tokens, metadata comparisons, and delta checks.
Okay, that sounds intense.
It is. The software is constantly asking the server, hey, has anything changed? Am I still allowed to view this? And when that handshake fails, the software enters a defensive holding pattern to prevent data corruption. It just stops.
So the Cowabunga technicians get the call. They start troubleshooting the local machines there in New Valley, but they realize pretty quickly that the local software isn't the root of the problem.
Right, because to actually figure out why that authentication handshake is failing, they need to go a level higher. They have to log into the company's Microsoft 365 tenant to look at the administrative logs.
And we should probably clarify that term for anyone unfamiliar. Think of a Microsoft tenant as your company's private, secure, digital office building in the cloud.
That's a great way to put it. It houses your email server, your SharePoint files, your user directory, and all your billing information. You hold the master keys to that building.
And unlocking that building is the exact moment this routine service call mutated into an active, high-alert security incident.
Yeah, the shift from a standard maintenance ticket to incident response is always jarring for an IT professional. It's like you are looking for a leaky pipe in the bathroom, and you open the wall to find out the entire foundation of the house has been dug out.
That is a terrifying image. But here's where it gets really interesting. The technicians log into that Microsoft 365 admin center for the New Valley business. And sitting right there in the active user directory are 5 completely unknown, unauthorized user accounts.
5 rogue accounts for a small business tenant is just a staggering number. I mean, it indicates a massive failure of the external perimeter.
5 ghosts in the machine. Nobody at the company recognizes the names. Nobody authorized their creation.
Wow.
And here is the detail that immediately impacts the bottom line. Every single one of these 5 ghost accounts had a business standard license assigned to it.
Which means the attacker wasn't paying for these accounts. The New Valley business was.
That's crazy.
Yeah, because Microsoft bills per license. When an attacker creates a new user and assigns a license, the system just automatically tacks that monthly fee onto the company's credit card that's already on file.
So it's an immediate, quiet financial drain. But as bad as bleeding licensing fees is, I have to imagine the security implications of those specific licenses are much worse. What does a business standard license actually give a hacker?
Oh, it gives them a full suite of enterprise-grade tools. They get a legitimate company-branded email address. They get access to SharePoint, Teams, and OneDrive.
So they are fully equipped.
Exactly. If a bad actor didn't assign a license, the account would essentially be an empty shell with no functionality. By assigning a business standard license, they are fully arming themselves with the trusted infrastructure of the compromised company.
Wait, I have a question about that. If a hacker manages to steal your administrative password and gets the master keys to your digital office building, why wouldn't they just, download all the sensitive client files, steal the data, and disappear into the night?
That's a really good question.
Right. Why go through the trouble of creating new user profiles and setting up licenses? It feels like they're taking the time to build a furnished guest room in a house they just broke into.
In cybersecurity, we refer to this concept as persistence. A smash-and-grab data theft is a one-time payday. But modern cybercrime syndicates, they operate like actual businesses.
They want a steady paycheck.
Precisely. They want a reliable, long-term revenue stream. If they just rely on the stolen admin password, they lose all access the moment the business owner gets suspicious and changes that single password.
So they are building backdoors that the owner doesn't know about.
They are building 5 backdoors. Even if the admin password is changed, the attacker still has 5 separate, fully functional hidden accounts they control.
Okay, so how do they actually monetize those hidden accounts? What's the day-to-day operation of a ghost account just sitting there in a small business network?
They use them for a technique called business email compromise. Because these rogue accounts have official company email addresses, say, accounting@novellibusiness.com, they easily bypass external spam filters.
Oh, because it's a real email address from a real domain.
Exactly. The attacker will sit quietly in the background and just monitor internal communications. They wait for a large transaction to occur, like an invoice to a major vendor or a wire transfer for a real estate closing.
They just sit there and watch the emails fly back and forth.
They watch and then they intercept. They will use their rogue account to reply to the vendor saying something like, hey, our banking details have recently changed. Please wire the funds to this new routing number.
And it works because it's coming from inside the house.
Right, because the email comes from the actual verified Microsoft tenant of the business. It looks completely legitimate to the recipient.
But wouldn't the real business owner see the confused replies from the vendor?
Not if the attacker knows what they're doing. To ensure the real business owner never sees those replies, the attacker will set up hidden inbox rules.
Oh, like filtering.
Yeah, they automatically route any incoming email containing the words invoice, wire, or fraud straight to a hidden marked as red folder.
That is deeply unsettling. It's literally a parasite, using the host's resources and reputation to thrive, all while hiding the symptoms from the host.
Which is exactly why the Cowabunga technicians immediately initiated a lockdown protocol the second they saw those accounts.
Right, they realized the house was compromised. The case study outlines their immediate response. First, they forced a global sign-out, killing all active web sessions for those unauthorized accounts.
A crucial first step.
Then, they blocked the sign-in ability completely, so the accounts were frozen. Next, they reset the passwords to something entirely random. And finally, they stripped those expensive business standard licenses so the client stopped bleeding money.
That is textbook incident response. You stop the bleeding and you freeze the environment.
But reading through their response, I found something really counterintuitive. If I find a digital intruder in my network, my immediate instinct is to hit the delete button. I want them erased.
Oh, for sure. That's human nature.
So why go through this elaborate process of blocking, locking, and resetting? Why not just delete the accounts and vaporize the ghosts entirely?
Hitting the delete button is incredibly satisfying, but from a forensic and legal standpoint, it is a massive mistake. If you delete the account, you basically destroy the crime scene.
So you lose the trail of crumbs they left behind.
You lose the server logs entirely. If this business later discovers that sensitive client data was stolen, Or if they fall under compliance regulations that require them to report a data breach to the authorities, they will need a professional forensic investigation.
And investigators need data to work with.
Exactly. Investigators need to see exactly when those ghost accounts were created. They need the IP addresses of the logins to track geographic locations. They need the audit logs to see exactly which SharePoint files the attacker opened.
And deleting the account wipes all of that.
When you delete the user account in Microsoft 365, much of that historical telemetry is permanently purged. You blind your own investigators.
That makes a lot of sense. You lock the ghosts in a glass box so you can study them. But that still leaves a glaring question. How did the bad actor get the administrative keys to create the ghosts in the first place?
The root cause.
Right. And this brings us to what was uncovered by the technicians. The source material notes that the admin account's two-factor authentication, the 2FA prompt, had stopped working on the office manager's phone.
If we connect this to the bigger picture, this is the crux of the entire vulnerability. Two-factor authentication is the absolute strongest shield your digital identity possesses.
Without a doubt.
It ensures that even if an attacker buys your password on the dark web from a previous breach, they cannot authenticate without the physical device that generates the second code.
Wait, if the 2FA app on her phone broke, wouldn't they just lock the office manager out of her own account? Does Microsoft just shrug and let people in with only a password if the Authenticator app stops responding?
Not if the system is configured securely, but many small businesses have legacy configurations.
What do you mean by legacy configuration?
Well, what often happens is a user gets a new phone, the Authenticator app doesn't migrate properly, and they request a temporary bypass. Or the tenant's conditional access policies aren't strictly enforcing the block on legacy authentication protocols.
Okay, I see.
Attackers run automated scripts 24/7 against business domains. They already have the password. They're just endlessly knocking on the door, waiting for that 2FA shield to drop for even an hour. The moment the policy falters or the 2FA is temporarily bypassed, the script logs in.
Well, it just walked right through the front door because the deadbolt was disabled. So to fix this, the IT team had to remove the broken 2FA configuration entirely and re-enroll her device from scratch.
That's right.
But they didn't stop at just fixing the admin account. The case study outlines a crucial rule they enforced. They reset every single known password across the entire organization.
There is zero room for assumptions in a breach. Once an attacker holds administrative privileges, you must assume lateral movement has occurred.
Lateral movement meaning they hopped from the admin account into other employees' accounts.
Correct. The attacker might have downloaded the global address list. They might have quietly generated application API keys that allow their software to read emails without needing a password at all.
Oh, wow. So just fixing the admin isn't enough.
Not at all. If you only secure the administrative account, the attacker simply logs back into the receptionist's account tomorrow using a credential they harvested during their initial dwell time. You have to force a complete systemic refresh to sever all potential connections.
Okay, so the perimeter is secured, the 2FA is locked in, the passwords are changed, the ghosts are frozen, the active fire is out, but we still have to fix the plumbing.
We do. We have to go back to the beginning.
Yeah, the technicians have to go all the way back to the symptom that triggered the call in the first place, the local OneDrive sync issue.
Because the symptom that brought them there is still causing the business owner grief.
And it was a really stubborn symptom. The standard fix for a broken sync is to remove the account from the desktop app and re-add it. But when the technicians tried this, they hit a brick wall. An error code popped up 0x800-48823.
Ugh. That specific alphanumeric code is a notoriously frustrating roadblock for IT professionals. It signifies an authentication failure, but the twist is that it's not failing because the user is typing the wrong password.
So what is actually rejecting the login?
The culprit is a built-in Windows component called the Windows Credential Manager. To understand why it fails, you have to understand why it exists.
Okay, lay it on me.
Historically, IT systems forced users to type their complex passwords every single time they accessed a network drive, an email client, or a web portal. It was secure, but users hated the friction.
Right, nobody wants to type a 16-character password 50 times a day.
Exactly. So Microsoft introduced Credential Manager. It is an encrypted digital vault on your local hard drive. When you log into OneDrive successfully, Windows quietly saves a secure authentication token into this vault.
That makes sense.
The next day, when OneDrive boots up, instead of asking you for a password, it just reaches into the vault, grabs the token, hands it to the Microsoft server, and says, hey, we've already been verified. It's an invisible convenience.
Let me see if I have this mechanism right. It's like You lose your hotel key card. So you go down to the front desk. They verify your ID, cancel your old card, and hand you a newly programmed key card.
Okay, I follow.
But when you walk up to your room and tap the new card, the door's offline battery-powered lock hasn't received the network update yet. You have the physically correct, newly issued key in your hand, but the computer inside the door is still referencing yesterday's valid data list. It just flashes a red light at you.
That is a highly accurate analogy. The vault on the local computer is stubbornly holding on to the stale credential. When the IT team forced a global password reset across the New Valley organization, the old authentication token stored in Credential Manager became mathematically invalid.
But Credential Manager didn't know that.
Exactly. So every time the user tried to open OneDrive, Credential Manager aggressively intercepted the login attempt, handed the Microsoft server the dead token, and the server kicked back error 0x800-48823.
So it's failing so fast, the user doesn't even get a chance to type the new correct password.
Precisely. To resolve the error, the technicians had to bypass the OneDrive application entirely. They had to navigate into the Windows control panel, open the Credential Manager vault, locate the specific line items from Microsoft Office and OneDrive, and manually delete those cached tokens.
They basically had to wipe the vault's memory.
Yeah. Once those stale tokens were destroyed, Credential Manager had nothing to hand the server. This forced OneDrive to actually prompt the user with a blank login screen.
Finally.
The user typed the brand new password, a fresh valid token was generated, and the authentication handshake finally succeeded.
And that's exactly how the case study wraps up the technical side. After wiping those stale credentials, all the OneDrive accounts were seamlessly re-added. The Delta checks resumed, the files populated, and the New Valley business was finally back to real-time collaboration.
Resolving the technical error is satisfying, but recognizing the underlying compromise is what saved that business from a catastrophic data event down the road.
Definitely. Before we zoom out, I want to mention a really practical quick tip the source material noted. The Cowabunga technicians didn't just fix the code, they helped the client with a major usability headache regarding folder names. Have you ever seen Windows add a tiny one in parentheses to the end of a folder name?
Oh, the duplicate naming convention. Yeah, it happens constantly when a user operates both a personal Microsoft account and a corporate Microsoft account on the exact same machine.
Right. Windows tries to sync both accounts to your hard drive.
Hmm.
But because both folders request the exact same file path name, usually just the word OneDrive, the operating system encounters a collision.
It doesn't know what to do.
Exactly. It can't have two identical folders, so it arbitrarily slaps a 1 in parentheses on the end of the second one. For the user, this is a nightmare. They end up saving a critical financial spreadsheet into the folder containing pictures of their golden retriever because the names are nearly identical.
The technicians taking the time to map out those file paths, rename the shortcuts, and verify the client understood exactly where their data lived is a hallmark of excellent service. Fixing the broken token is only half the job. Ensuring the user can actually navigate the restored environment is the other half.
So what does this all mean? We started this deep dive with a frustrated office manager staring at a spreadsheet that wouldn't update, and we ended up uncovering a breached network, rogue backdoor accounts, and a complete failure of the security perimeter.
The overarching lesson here is that in a heavily integrated cloud environment, symptoms are rarely isolated events. An ignored sync issue, a device repeatedly asking for a password, or a slight delay in email delivery, these aren't just inconveniences, they are diagnostic alarms.
This is especially vital for the audience. This case study centers on small business owners and office managers, particularly out there on Oahu, who run their entire daily operations through Microsoft 365. Your emails, your vendor contracts, your shared financial data. If that digital ecosystem is compromised, your actual business is compromised.
You cannot assume that because you haven't received a massive ransomware demand, your network is secure. Silent compromises, like the deployment of persistent ghost accounts, are far more insidious because their entire design relies on you ignoring the small anomalies.
Which is exactly why you need a team that looks past the surface. You need technicians who look at a stubborn error code like 0x800-48823 and immediately think, hey, before we clear this cache, let's verify the admin logs just in case.
It's a completely different approach.
And that brings us to the methodology of the folks who handled this response. If you are listening to this and realizing you haven't had a professional verify your network logs in a long time, you need to know about Cowabunga Computers.
Forensic IT requires a specific mindset. It requires technicians who understand how attackers monetize vulnerabilities, not just how to reboot a router.
Absolutely. The technicians at Cowabunga, guys like Brandon, Steven, Ripton, Jose, Kaylee, Elijah, and Cassie, they utilize this exact investigative methodology every day. They help homes and businesses all over Oahu with computer repair, managed IT, complex networking, and security consulting.
They dig deep.
They don't just treat the symptom, they diagnose the disease. So if your Microsoft 365 is throwing weird errors, or honestly, if you just want a comprehensive security audit to ensure you don't have 5 ghost accounts silently reading your invoices, reach out to them. You can call the team directly at 808-468-4416, or check out their services online at www.smartcows.com.
Proactive auditing is vastly less expensive than reactive incident response after a wire transfer has been stolen.
Which brings me to a direct challenge for you, the person listening to this right now.
Yes.
Yes, we want you to take a hard look at your own digital infrastructure today. Here's the question. When's the last time you actually looked at the user list in your Microsoft 365 Admin Center? Do you even know how many accounts are in there right now?
The vast majority of business owners have no idea. They set up the tenant years ago and never look at the user directory again.
Change that today. Take 5 minutes. Log into your admin center. Look at your active users. Review exactly who has licenses assigned to them and what those licenses cost. If anything looks off, a name you don't recognize, or a former employee whose access was never revoked, call Cowabunga. Computers before that loose thread unravels your entire business.
And as you investigate your own network, I will leave you with this to consider. If a massive targeted security breach can successfully masquerade as a simple, annoying file sync error, what other minor tech glitches in your daily life are you actively ignoring right now that might actually be trying to tell you something urgent?
Don't ignore the clicking sound in the engine. Thanks for taking the deep dive with us. We'll catch you next time.